All right, so now that we've learned all about this delegate call function and what it can do and the power of it, let's actually put it to use. Let's actually build an upgradable contract example so we can really see this power. So let's go ahead and let's start doing this. Of course, all the code that we're going to be going over with is available in the GitHub repo associated with this course if you want to follow along. So let's go ahead, make a new directory, Foundry upgrades -F23. Let's code Foundry upgrades F23 or file open folder. You know the drill. Now, I know in that video, we talked a lot about this transparent proxy pattern versus the UUPS. We're actually going to be teaching the UUPS proxy. In the UUPS proxy, the upgrade is handled by the implementation and can eventually be removed. And this is incredibly important, especially if we want to heed my warning I made at the beginning, where we want to really do this as little as possible. And this is kind of a crutch to get started. And we've seen issues where if you have upgradability and you have a centralized entity that can upgrade and change your contracts, those are often exploited. So the UUPS proxy allows us to eventually remove the upgradability so that the code is truly immutable. And also, UUPS proxies are technically a little bit cheaper to deploy. You can read more about the differences between the two proxy types in the documentation for OpenZeppelin. And additionally, if you go to the contract wizard in OpenZeppelin, most of these types in here have a upgradability option with UUPS that we could even open in Remix and see exactly what some of these might look like. So we're going to be going through that with our own example here. So we're going to go ahead. We're in our folder. We're going to do forge init, of course. And we're going to go and delete these once again. Goodbye, goodbye, goodbye. Delete with the trash. I held down command so I could select all three. And let's create a very minimal contract that we're going to actually upgrade. So we're going to say a box v1.sol, and this is going to be what we're going to upgrade. So in this box v1, we're going to do SPDX, license, identifier MIT, you know the drill, MIT, pragma solidity 0.818 with a little caret here. Contract box v1 like this. Cool. Now, so since we're using the UUPS proxy, we're actually going to need to add all of the proxy upgradability into this contract as well. So we can actually borrow from OpenZeppelin, kind of like what we were seeing here, because they have all of these contracts already created for us. But let's actually just write out what we'd want our box to do first, and then we'll go ahead and do that. So we'll say a uint256 internal value or number, a little bit less confusing. We'll have a function get number, public view, or better yet, external view returns uint256, return number. All of this is something you all get because you did the stablecoin video, which was a monster of a project. Version external here returns uint256 return 1, and that's it. This is all our box is going to do. Now let's copy this box. Let's go to our source. We'll create a box v2.sol, paste all that in here, and let's change this a little bit. Let's have the version return 2. Get number will still return number, but let's add a function set number uint256 underscore number. So be external, null, like this. But so here's, oh, and this, rename this to box v2. Okay, cool. So now we have our box v1. We're going to deploy box v1, and then at the contract address of box v1, we're going to upgrade it to box v2. Now remember though, if we upgraded it, changed some storage variables, we would mess it up, right? So if you go to the OpenZeppelin documentation, let's actually reopen this back up in Remix here. We can see kind of what's going on here. So this token example that they have, they say it's initializable, upgradable, ownable, and UUPS upgradable. They say it's all this stuff. So for us, we're going to go ahead and we're going to install this OpenZeppelin contracts upgradable package. And this is actually at a different OpenZeppelin repo. If we look up OpenZeppelin contracts upgrade, GitHub. there's this OpenZeppelin/OpenZeppelin contracts upgradable repository that we can use. And this is the one that we're going to want to install. So we're going to copy this like that, forge, install this --no -commit. All right, great. We've installed it. Now we can start using these contracts upgradable code in here. Let's just go in here, do a remappings equals, we'll say at open Zeppelin / contracts upgradable equals lib / open Zeppelin. And let's do a toggle word wrap. Zeppelin contracts upgradable / contracts. Hopefully that looks right. Let's go to lib. Opens up a contracts upgradable. Yep, that looks right. Okay, cool. So now we can start using this. So in this remix example, it can be a little bit confusing because there's a lot of imports going on, right? So let's kind of break this down. So the first thing that we're going to need is going to be this UUPS upgradable contract. And I'm just going to copy this line. Feel free to copy this line as well, or write it out yourself. And I'm going to toggle the word wrap here. And of course, we're going to do named imports because we're good engineers. What did I mess up? Oh, I don't need this versioning. Okay, cool. And if we control click into this, or we command click in this, or we just open this, we can see exactly what is in this upgradable code here. So we have this UUPS upgradable contract. It's initializable. It's some proxy stuff, yada, yada, yada. If we scroll down, it's got some modifiers. It has this function upgrade to, address new implementation, upgrade to and call, and it has this gap at the bottom. So let's talk about these. So this upgrade to function, this is the function that gets called when we want to upgrade our box. So we're going to say our box is UUPS upgradable. And then it's going to say, hey, it should be marked abstract because we don't have all of the functions defined in here. And this contract is actually known as an abstract contract. Abstract contracts have some functions defined and some functions undefined, and they expect their child classes to implement those functions. So for example, at the bottom here, we have this authorize upgrade function, which isn't defined. So an abstract contract basically says, hey, you better define this authorize upgrade function because I'm not going to do it. You need to do this. And this can be helpful for a lot of reasons, right? For example, let's say you want to make sure to not forget to add some function. So this is something that we're going to need to define. These are how we're going to actually do the upgrades. We see that this is, obviously the function that we're going to have to define. So we can add authorization parameters in here, such as who can actually do the authorization. So if I toggle the word wrap, we can see function that should revert when message.sender is not authorized to upgrade the contract. So for example, if you wanted your proxy to be owned by a DAO, you would update this to be ownable or only owner or something like that. But then they call this upgrade to and call UUPS, which if we control click into, or we just go to where it's defined, we toggle the word wrap here. We can see this performs the implementation upgrade with security checks for UUPS proxies and additional setup. So if we scroll into here, this is the code that's actually doing the upgrade, and it's really low level, right? So we'll call this function set implementation, which now routes all contract calls via delegate call to this new implementation address that we set. And then it does a couple of checks in here, and then it calls upgrade to and call, which calls upgrade to, which calls set up implementation, which mainly just sets the implementation slot, which basically, like I was saying before, it says, okay, all contracts are going to be routed to this address now, right? But if we go all the way back, that's kind of the long of what this upgrade to is going to do, right? So it's going to change where we route all of our delegate calls. And then if we have any data we want to send, it'll call this as well. The data is obviously going to be none if you just call upgrade to. Anyways, I'm getting kind of in the weeds here, right? This is the function that it has set up to do the proxy stuff we showed before, right? This changes the implementation address. So we obviously need this. We also need to implement our own authorize upgrade function. So we can just go ahead and copy this. And in here, we'll paste it in here. And for us, we need to make this override instead of virtual. I'm just going to leave it blank because I don't really care. I don't want any authorization stuff in here, right? But this is where I'd put like, require, or excuse me, if, message.sender does not equal owner, revert, right? Right. But for us, I don't really care. So I'm just going to leave it blank, right? And so this is going to say anybody can upgrade this. So this is why this is going to be the most important one, right? This UUPS upgradable is doing all that proxy upgrade stuff. All right, cool. So what else? Now, you'll also notice here at the bottom, there's this gap thing. Now, you can read the docs here. This empty reserve space is put in place to allow future versions to add new variables without shifting down storage in the inheritance chain. What the heck? What are you talking about? Storage gaps. The reason these proxies work is that they point to the slot number instead of the name of variables. So if I were to upgrade from box v1 to box v2 and I put in other number here, guess what? If I did this upgrade, whatever number was in box v1 is now set to other number instead of number. This is because proxies point to storage slots. They don't point to variable names. They point to storage slots. If we upgrade to v2, other number is now in storage slot 0, whereas number was in storage slot 0 over here, right? So what is the best practice to do is to have this gap at the bottom. So a uint 256, you can put really whatever number you want here, which basically just says, hey, we're going to save 50 storage slots in storage for adding new variables in the future. You could have this be, 100, whatever amount you want, right? And this is just so that in the future, if you need to add more storage slots, you don't collide with other places that storage is already being reserved. So it's really important that they have this gap, especially for UUPS. If this doesn't make sense, definitely 100% be asking questions about it. And you'll see a lot of people will even manually add their own gaps sometimes. So sometimes you'll even see somebody go, like gap 2 or whatever they want, right? So they have additional gaps, whatever they want to do. Cool. So this is why we need this. Now, right like this, we could ship this code and this would be upgradable. Now, of course, box v2 is not upgradable, but box v1 would be upgradable. So why is Remix adding all this other stuff? What is initializable? Well, let's copy this and let's paste it in. And you can also see all this weird initialized stuff. What is going on with that? Well, let's add this in. And of course, we're going to do a named proxy. If you want to write this out yourself, feel free. Excuse me, we're going to remove this because we did not add the version in here. Initializable. So what is this? Why is OpenZeppelin telling me I got to do this initializable thing and it's doing all this weird initialized stuff? So let's go into initializable. Oh, and if it doesn't let you do that, let's open up our file explorer. We'll look for initializable.so and let's see, let's read this. So if you want to pause and you want to read this, I'm even going to toggle the word wrap. If you want to pause and you want to read this, feel free to do that. But the main thing we know is this piece here. Since proxies contracts do not make use of a constructor, it's common to move constructor logic to an external initializer function. You might be thinking, wait, what? They don't use a constructor? Remember, storage is stored in the proxy, not the implementation. So we have proxy, which will direct all calls to the implementation, but it's like borrowing the implementation functions, right? So all the storage is happening over here. If the implementation has a constructor and it sets number to 1, right? The proxy will have number still set to 0. Because when you deploy a contract, the constructor gets called from the implementation. So proxy contracts or contracts that are meant to be used via proxy don't use the constructor. So what you need to do is then with a proxy, you need to deploy implementation. Then you need to call some initializer function. Now the initializer function is going to be essentially your constructor, except for it's going to be called on the proxy. So that's kind of the difference. If that doesn't make sense, please ask questions about it because it's really important. So constructors are not used in proxy contracts. So what a lot of upgradable contracts do is they call this disable initializers function in constructors, like you see here. And I'm actually going to copy this, paste it into my box v1 like this. And then often you'll see this comment. I'm going to paste this over here because sometimes different linters will say, hey, you're using a constructor in a upgradable contract. You shouldn't do that. So we just say, hey, like, let it happen, right? What this disable initializers function does is it says, hey, don't let any initialization happen. So if we go see this, we say require that you're not initializing, right? You can't call any initializer functions. So you could just as easily just do this, right? They're kind of the same, but this is much more verbose, right? This is making sure, hey, don't do any initializers. Constructor, don't do anything. So this and this are almost the same, but this is more verbose. As you know, verbose is better. But let's say we do want a constructor. What we would do is we'd add an initializer. So we do something like function initialize public initializer. Initializer. And of course, we'd say our box v1 is initializable, public initializer, like this. And we would add whatever we want to initialize. And then what we're going to do is we're going to deploy the contract. And then we're going to have the proxy immediately call our initialize function. Instead of doing this constructor, instead of the implementation having the storage, we want the proxy to have the storage. Typically, you'll see initializer functions have 2 underscores like this. So if we want our box v1 to have an owner, right, we can't set storage. We can't do like owner equals message.sender in the constructor like we normally do with a ownable contract. Instead, we need to put that in the initializer function. So what a lot of people will do is they'll add double underscore like ownable underscore init. Like let's say we did want this to be ownable, and actually let's go ahead and add that right now. We're going to add this ownable upgradable. I'm going to paste it in. I'm going to remove that ownable from like this, comma. I know I kind of was quick, but I know you all are advanced enough to kind of know what I just did here. I refactored this a little bit. So that's a named import, remove the version. And now we're doing this ownable upgradable instead of ownable. I'll explain what that means in a second. Oh, and this actually goes here. A note, if you see this linearization of inheritance graph impossible, this means that we're trying to inherit stuff in the wrong order. So we'll just do this. Oh, is that the right order? No, that's still the wrong order. Is that the right order? Cool, that's the right order. Okay. So what you'll see is these upgradable initializable functions will be prepended with double underscores, right? And so what this is doing is it's setting the owner to message.sender. And if I command click into this, or I command click into this, we look up ownable init. We see it does this ownable init unchained. All it's doing is calling transfer ownership, right? That's it. This is essentially the same as setting owner equals message.sender, right? But we're just prepending it with the double underscore to say, hey, this is an initializer function, treat it as such, right? It should only be called in this initialize section. Additionally, most of the time you'll see this initializer function, which doesn't do anything, but it's best practice to have this in here to say, hey, this is a UUPS upgradable contract. We're going to treat it as such, okay? So you'll see this in here a lot too. But I know I kind of went through this a little bit quickly, but let's just do a quick recap of what we learned. We can't use constructors with our proxies. A constructor adds storage to the implementation. And if we have a proxy pointing to an implementation, the implementation would have the storage of where the owner is, and we need the proxy to have the storage of where the owner is. So we need to call initialize through the proxy, not through the implementation. The initializer function is essentially a constructor for proxies. You can almost think of it like that. We want to prepend them with this double underscore to know that they're initializers, and we don't want any initializers to run in the constructor, and we only want them to run once. You'll also see this initializer modifier, which basically just says, hey, you can only initialize one time, right? A contract can only be initialized once, otherwise it'll error. Great. And that's pretty much going to be our box. So now we made this ownable. So since this is ownable, down here in our authorized upgrade, we could add an only owner modifier in here so that only the owner could upgrade it if we wanted to. But we're not going to add that, but I wanted to add this ownable init here just to show you, hey, like, so this is what you do instead of working with constructors. So that's our box v1. Let's fix our box v2. So our box v2, we're going to do pretty much the same thing. So we're going to grab all these, paste it in here. I'm going to toggle the word wrap. We're going to make this initializable, ownable upgradable, and UUPS upgradable is like this. We're going to need to add authorize upgrade, which we're going to keep blank. But if you want to play with this, you can obviously implement this. We're going to want to add a constructor and an initializer. So we're going to copy both of these and just paste it right in here. A constructor which disables constructors, and then an initializer, which is going to be really what we want. And that's pretty much it. That's the only changes that we need to make. Now we can make this even smaller, right? We could say, okay, cool. We don't care about upgrades. We don't care about initializing. And we just say, goodbye. This doesn't need an initializer. This doesn't need any of that stuff. And we could even delete all of this if we wanted. And now it's just UUPS upgradable, right? Without any initializer and without any constructors. And we can do the same thing with box v1, but I just wanted to demo what it would look like if you did want a constructor. But now that we've done all this work,